All right, so we're spending some time looking at class diagrams, how are we going to design them and come up with them, and try to see if we can capture the information we want, and eventually we want to be able to convert them into their relational schema counterpart, and vice versa, from the relational schema into a visual diagram. So when you read the diagrams, the class diagrams, right? It makes it very easy, right, to just look at the diagram and visually inspect it, and ask yourself, well, what can I retrieve? What kind of queries can I make of this diagram, right? Can I answer certain questions and certain things that you cannot answer, right? What can't I answer? So, for instance, by looking at the diagram, we can certainly be able to answer things such as, I see that students are enrolled, and the section has a bunch of courses, and we can answer things such as what courses is a particular student enrolled in. I can answer those questions. Who's teaching a particular student, right? Who gave them the grade? I can, when are they graduating? What particular year did they take the course? What the size of the particular section was for that particular course. I can answer these things. But um, the now there are a couple of things that I know that I oh man, excuse me. There are a couple of things that I know I can't answer, right? So, for instance, what are the office hours of the faculty? I don't know. It's not captured here. Did the student change from one section to the other? Nope, it's not captured here as well. Was there more than one professor teaching this, and they were co-teaching it? So there are a few things that certainly not being captured, right? Any history of employment that the professor came in and left and then came back, none of that is captured here, right? And usually by perusing graphically, visually, you can immediately tell that these things are not being captured. Whereas if you had a schema, it would be much harder, to follow the arrows and what references are being captured. So graphically, as they say, the cliche, an image captures 1,000 words. So we need to be able to start thinking of how is it that we are going to transfer this graphical representation into a physical, concrete implementation, right? So we have these cardinalities, the ones, the stars, and whatnot. So they really are going to be implemented basically in foreign keys and primary keys, right? They're going to be converted into those things, which we're not capturing, right? Typically, you would not capture this in UML diagrams, okay? The UML diagram would typically be agnostic of how you're going to actually implement the data set. It could be implemented in Java, where there are no primary keys and foreign keys. It would be irrelevant that you would capture the fields primary key and foreign key in a UML diagram, right? It could be implemented in C#. It could be implemented as a JSON object. It could be implemented as XML. None of those use primary keys and foreign keys. Make sense? Okay, so typically you would not capture those fields. Those fields are specific to the relational schema implementation. Yes, right? Now, you could, depending on who your audience is in the UML diagram, if your audience is a DBA, right, a database administrator, right, and we're using relational databases, then in that audience, you might choose as a business analyst or as an engineer, put in the primary keys and foreign keys fields in there, yes? So that it would help the discussion as you're discussing with your DB administrator, yes? But amongst engineers, as we're designing the data structure, typically we would not include them. Make sense? So depending on who your audience is, you might decide to include them or not. Okay. Also, this might be a non-relational database, right? So again, foreign keys and primary keys might make no sense here, right? So typically we think of UML as being a conceptual language, right, as opposed to an implementation language. So if we are indeed deciding that this is going to be implemented as a relational database, this is what it might look like, right? The student tables might look something like this, where you have a primary key, so of Alice, Bob, and Chuck, 1, 2, 3, 3, 4, 5, and 4, 5, 6, and you have notice that we don't have the foreign keys going from the student to the department. See that? Nowhere are we capturing that. So physically, there's no way to implement it, right? None of these are referencing one another. We have the sections. We have the sections ID. We do have the foreign keys here. I guess I must have forgotten over there, the putting the foreign keys over there. But notice we have the sections and the primary key. I forgot to put here the section ID, but I did want to just show that these stars and these ones and these annotations, have a physical representation when you're going and transferring this into a relational database, where the stars are going to be the foreign keys, right? And the ones are going to be primary keys. So the primary keys on the side of the one, and the foreign keys will be on the side of the star. Same thing here. These are the section IDs of the primary keys on the side of the one, and the star would be the foreign keys that are referring to those sections. Yes? Right. So there is a mechanism that could be an algorithm that allows us to go back and forth between these two worlds. Oh, there's a star? Oh, that must be a foreign key. There's a one? It must be a primary key. Yes? Okay. So we're trying to think of an algorithm to do this, right? So here we go. We have the foreign keys on the enrollment, referencing the primary key on the student. We have the foreign keys and the enrollment here, also referencing the sections as well. So primary keys and foreign keys, and foreign keys of the section referencing the course, and finally the departments from the courses. Right. So some of the limitations from this visual reading is that certain questions we could answer, certain questions we cannot answer. If a student changed the major, or if a particular professor advises a student or not. So they're not being captured in the database.